So now that I have the important things I need for a polar number here, I can do that. I can say just a standard z is a radius of 2, cosine of 150. Don't forget the I and the sine of 150. So this guy right here is the exact same thing as this guy. One's rectangular, one's polar. Now, I need to take this and raise it to the fourth. So this is going to the fourth, and this whole thing is going to the fourth now. Once I have it in that form, all you got to do is follow the formula. So the cosine, it's now the power times the value in there, because that's what our formula says, n times theta. I encourage you guys not only make sure you have some good examples here in your notes you can look off of, but take the time and write these steps down. So this is going to be cosine of 600 degrees plus I sine of 600 degrees. Now we look at what the problem wanted. It wants it in a plus bi form. So we're in polar form right now. So all we got to do is go transform this. Okay, literally just plugging in cosine 600, sine is 600, and distributing. Before I do that, though, I'm going to get this to values that we know. So 600's outside our unit circle. $240. Okay, so I'm going to pause it here. I'd encourage you guys to draw a triangle, plug in the values, and see what happens. And I'll meet you after the pause with our answer. So I went over to the side, drew a little triangle. You guys can use your yellow sheets, but understand how I don't have these memorized. I just kind of draw them here. Cosine 240 is negative 1/2. Sine of 240 is negative square root of 3 over 2. So both these guys should be negative. Okay, distribute the 16 is negative 8. Also a negative 8. Don't forget the I and the square root of 3. So this is what happens when you raise this guy to the fourth power. So a lot of stuff in the middle all cancels out, and that's what you get. Here's the book solution. They kept these in radians. Understand it's going to work exactly the same. You guys can look at that if you're interested. They get a 10 pi over 3. That was our 600 degrees. Answer still looks exactly the same. Okay. Now, here's where it gets a little goofy. The complex roots. So going back to this graph. Okay, that guy clearly has complex roots. That's in Cartesian. That's rectangular x and y's. If we're in polar now, we have this little theorem that finds them. So W is a given complex number, okay, whatever it is. Z to the n is a complex number to the n greater than or equal to 2 power. So z squared, z to the third, something like that. So z to the n equals W provides the complex nth root. Okay, so we're trying to find the square root or the cube roots or the fourth roots or the fifth roots. Okay. Here's the formula. So zk, so this tells us the roots. It's the nth root of n, cosine of theta divided by n, plus 2 pi k divided by n. So you've seen the 2 pi k before. You could just as easily replace that with 360. It might be easier for you to do these in degrees. Plus the I sine theta over n, plus 2 pi k over n as well. Okay, that's something you got to have. You don't have to memorize it, but make sure you have access to it that we can look at it. Okay, this will tell us how to find all the complex roots we need. So here's the problem. Find the complex fifth roots of -2 square root of 3 plus 2i. So clearly that's a complex number in rectangular form. Okay, we want to find the fifth root of that, or fifth roots. We want to find 5 different roots. So different things that we can raise to the fifth power to get that number there. Okay, so this is going to put a lot of different steps together. First thing I'm going to do is take this, figure out where it's at. Well, it's in quadrant 2 again. Not sure why everything always ends up there, but it's just what happens. Okay, first thing we got to find is our radius. I guess this is radius squared. So this radius equals 4. Now we got to find how far we need to tilt it. So we found the 4, okay. Understand it is in complex, so we're going to have to account for that I in a little bit here. Now, I'm going to use a sign here. We'll call this theta 1 because I'm confident my radius is correct. Okay, you guys can use a tangent, cosine, whatever, but this is practicing adjusting it, getting it in the right quadrant. So I'm going to say sine of this is 2/4. I'm going to be in degrees, and I'm going to inverse this. Okay, 30 degrees. Now, that means this is 30, okay? There isn't an inverse sign that happens in quadrant 2, only here and here. So to get all the way over there, that's 150 degrees. So before I even try and find fifth roots, I just have to write this guy right here as this. All right, now that I have that, okay, I want to find the complex fifth roots. Here's what I want to do. Fifth roots, that's going to tell us what the n is. Now I can go to the formula. You get this little note here, find the z to the k first. So we're going to get a general equation, then we're going to plug in values for it. So I don't want a decimal. Just say fifth root of 4. Cosine. Here's where we got to start following the formula. Our theta right now is 150 degrees. We're dividing this by n, which is 5. We need to add on 2 pi k. If I'm in degrees, I'm just adding a 360. So the other ways you can get back around to this point. And I'm dividing this guy by 5. Squeeze this guy down here. So just following the formula again. Okay. Now we take that guy, and we're going to have to simplify it. So I'm going to say cosine of 30 degrees plus 360 divided by 5. $72. Plus 72 degrees K plus I sine of 30 degrees plus 72 degrees K. And we'll pick up in part 3 and show you how to finish this guy up.